The unit 1 of the upper syllabus is wave optics. It comprises of three different chapters: interference, diffraction, and polarization. And the second unit comprises of two different chapters: lasers and fiber optics. Of course, you can call it as optical fibers also. Although there is a very small difference between fiber optics and optical fibers, at this stage you can interchangeably use. And the third one is magnetic materials and dielectric materials. These are two different chapters. And the fourth one is quantum mechanics and free electron theory. So from here onwards, it is a continuation of all these four chapters: quantum mechanics, free electron theory, and in the fifth unit, band theory of solids and semiconductor physics. All these four chapters are continuous chapters. So that's why the syllabus was prepared like that. And these are the textbooks. Actually, you're required to follow. Okay, so four textbooks were prescribed. The library has all these books. Apart from the material given to you, you can go through these textbooks also, understand the concepts in a deeper way. And apart from these textbooks, we will start the reference books also. And I will give you the web references also if you are interested to follow. Better to follow. Anyway, there are so many videos, video lectures are available to understand the above mentioned complete syllabus part. So in that syllabus, you can see, you see, so the interference is the first chapter of the wave optics. So we will start with the interference. So in this, initially we have introduction, then interference in thin films by reflection, Newton's rings, both theory and experimental study is there. And another important thing is you have the experiment also in our laboratory. Newton's rings experiment is also there. So both theory and the laboratory experiment is also incorporated in your syllabus for your understanding, better understanding. And after that, applications of the Newton's rings. Two basic applications were there. Wavelength of a given source can be determined using Newton's rings, and refractive index of a liquid can also be determined using Newton's rings. So these are the contents of the first chapter of first unit. So we will start with the introduction. So after introduction, actually we need to fill a gap between these topics: introduction and interference in thin films. In between, there are few topics are there which are not straight away incorporated in the syllabus, but you need to learn those topics to understand the further topics. Okay, so we will start with introduction, and the required topics which are not there in the syllabus will also be discussed, and then we will move into the interference by thin films. Okay. Now, See, the light's nature. The light nature is a very important and significant area of study that has been going on for a very long period of time. So anyway, there are two parallel theories with the light: wave nature of the light and particle nature of the light. Of course, initially we thought that so this is probably this corpus law theory of Newton. You might heard about this in your lower standards. So this is probably the very first theory proposed by Newton. According to this theory, light consists of particles which were termed by Newton as corpuscles. And these particles have a mass and can travel with extremely high speeds. However, later on, Huygens came up with another theory which is known as wave theory in 1680. Huygens wave theory. According to Huygens, light travels in the form of waves. So he opposed the Newton's theory. He thought that Huygens thought that light can travel in the form of waves. Newton thought that they can travel in the form of particles. So both these theories were very old theories, as you can see in 1670 and 80 respectively. However, both the theories have their respective examples also, which can support particle nature as well as wave nature also. So these are some of the examples for wave nature. So in 1800, Thomas Young performed an experiment familiarly known as Young's double slit experiment. So in Young's double slit experiment, Young proved that light is traveling in the form of a wave. And similarly, the interference in thin films is another important experimental evidence which confirms the wave nature. And of course, the next chapter actually diffraction, which is also confirms wave nature of light. So all these are proofs of Huygens theory, experimental proofs for Huygens theory that light can travel in the form of wave. However, there are some experiments. Of course, there is a long gap. You can observe here. It is observed in 1905. So by this time, Newton was not there. But these experiments are confirming that light can travel in the form of particles. So this particular experiment, photoelectric effect, is confirming particle nature of light. So the contrast is there between these two natures. Okay, and these also, the experiment was successfully explained by Einstein, and he got Nobel also for that. He gave the explanation for particle nature of light using quantum mechanical support. So Albert Einstein was awarded a Nobel for his contribution in explaining photoelectric effect. Of course, he is 10, but So now you may ask the question, which theory is right? Particle theory or wave theory? Whether the light is traveling in the form of particle or the light is traveling in the form of wave, which is correct? So that,
Wave, sir. In the form of
Wave,
wave.
sir. Wave.
sorry, I didn't get you. Some people, your voice is not audible to me. It's breaking. Anyway,
Wave,
both,
sir, wave.
yeah, you are voting for wave. Okay. Okay, somebody may also vote for particle because both wave nature as well as particle nature have experimental evidences. That is the interesting part. Wave nature has the interference experiments are there, which are confirming that light is
Sir,
traveling.
your voice is breaking and not audible, sir.
Excuse me,
Sir.
your voice is
Yes,
breaking.
sir.
Whereas particle nature can also have the experimental evidences. Like not only photoelectric effect, there are in modern physics there are some experiments which also
You
confirms
can't
the
understand.
particle nature. So this
Saplar che brother.
this duality. Okay, we will have the discussion anyway at the end.
Breaking. Your voice is breaking. Can't hear it.
Am I audible to you?
No, sir.
Now it is audible, sir. Before it is not. It isn't. It doesn't audible.
Okay, is it audible now?
Yes, sir.
Okay, both
Yes, sir.
both wave nature and particle natures are experimental evidences, and their respective theoretical verifications also there. So this duality of the light could be explained with the help of quantum mechanics, where de Broglie introduced the dual nature. That means it can travel either as particle or as
Sir,
wave.
your voice is not audible.
Okay. So, this is a visualization of first interference pattern. You can see here two sources are here. You observe the cursor. Two sources are here from where the waves are originating continuously, and these originating sources, both sources, are continuously generating waves. The generating waves are being superposed with each other. That means they are overlapping with one another. This overlapping of one another is referred to as superposition principle. We will discuss this in detail after you watch even after 10:35. The people are asking to join after 30 minutes of class. Are you able to see this interference of waves? Are you able to see this? Are you able to see my screen?
Yes, sir.
Yes?
Yes, sir.
You please observe it carefully. You see, here both reflection and refraction are being represented. One of light properties, these two are also light properties. Reflection will take place within same medium, whereas the refraction will take place when it is traveling from one medium to other medium. You can observe here two mediums are there. So in between, say these two are air mediums, so rarer mediums, and in between there is a denser medium. So when the light is entering from rarer to denser medium, its path is being changed. This is known as refraction. Refraction always takes place when there is a change in medium. So these are very basic properties of light. So two theories, corpuscular theory of light as well as wave theory of light. Both the theories were there. And of course, corpuscular theory was later on modified by quantum mechanics, which supports the particle nature of the light. You see, here you have the interference overall diagram, and here you have diffraction diagram. So these two phenomena, so both interference and diffraction phenomena, both can be explained with the help of wave theory of light. They successfully explained. Theoretical as well as experimental support is also there. Okay, you can observe here. This is a source. You observe my cursor. This is the source. Actual source is being generating light waves, and from this source we are deriving two other sources. You can call it as S1 and S2, source 1 and source 2. And again, these two sources are generating their individual waves, and they are being superimposed. You can observe this contrasted region. This region is referred to as the interference region. So forget about diffraction. We will discuss that in the later class. While we are dealing with the diffraction, we will discuss in detail. We just observe this interference pattern first of all. So this particular region is referred to as interference region. That means where these two light waves, are generating from two different sources, S1 and S2. So when they are superposed with each other, the intensity distribution is changing. That is what they observed actually. Okay. So this is what. Who is that 423? Kalyan. Why you are annotating? Don't you have manners? లెసన్ ఎలా వినాలని తెలీదా మీకు? So these are the waves generating from two different sources. You see, these waves are traveling in one direction, and these waves are traveling in the almost same direction. So when they are traveling in the simultaneously in one direction, at one point these waves tends to superpose with each other, which results into interference. This is the interference region. You see, this is what actually the interference is termed or can be defined is the combined effect of disturbances caused by each individual wave. That means if you want to understand the phenomena of interference, a minimum of two waves required to travel in a same medium in same direction. Then only the interference can be observable. If there are, there may be a chance of more than two waves also, but we are dealing with the simplest case. Here we are dealing with only two sources, S1 and S2, because that is the minimum requirement. It may be three sources, four sources, or n sources may also be there. But all these principles which are about to be discussed will be applicable to all the results. For three or four or n number of sources, we can apply it. Here anyway we are having only two sources, which is the most simplest case of the interference. So this is the one of the most important principle, which is known as principle of superposition. Principle of superposition. You just see on your left side, two waves are there, two different waves are there. You can observe them. They are mentioned in the different colors. Two waves with different frequencies are also there. The frequencies are also not there, equal for these two waves. Need not to be equal also. These two waves are traveling simultaneously. When they are traveling simultaneously, superposition will take place. So what actually superposition is? The displacements of these two waves will be overlapped with each other, and it results into a new wave. The new wave is observed in the right hand side. You can observe it on the right hand side. You see. Okay. You see, ఇప్పుడు ఈ ఎగ్జాంపుల్ ఏంటంటే దీన్ని రిపుల్ ట్యాంక్ ఎక్స్పెరిమెంట్ అని అంటారు. I think you might had it in your lower standard, definitely intermediate level లో ఉండాలి ఇది ఎక్స్పెరిమెంట్. Ripple tank experiment. When you drop a pin or an object into a very calm water of tank, then you can observe these kind of waves. Okay. In the nearby, if you drop another object, there also starts waves, originating of waves. These two waves tends to superpose with each other. You can observe here. You see. You see, in this region, the superposition is taking place. You can observe here, this particular wavefront is belongs to this source. Okay, and this particular wavefront is belongs to this source. Now these two are being overlapped with the number of wavelets. This is one case. We are just discussing one wavefront overlapping with the other wavefront. So this overlapping of the wavefronts with each other is referred to as a superposition. This superposition results into a change in displacement of the resultant wave. You see, here also they are depicting the same thing. So this is one way, and the in backdrop there is another wave. And when these two waves are superposed, the resultant superimposed wave have greater amplitudes. Okay, this is known as a superposition principle. You please note it down this statement. This is one of the most important statement of the interference. Interference is completely based on principle of superposition. So the statement is like that: when two or more waves travel through the same medium simultaneously, the resultant displacement at any point is the vector sum of displacement of due to the individual waves. That means if you assume that these two waves are traveling, here two waves are traveling, on the backdrop already you have seen two waves are traveling simultaneously. So at a given instant of time, say at t is equal to t1 seconds, what is the amplitude or what is the displacement? That's what actually superposition states. What actually is stating? When two or more waves, that's what I stated earlier. The sources may be two or three or n number of sources. That's why two or more waves travel through the same medium simultaneously. That means they are traveling in the same direction. Then the resultant displacement of these overlapping waves is the vector sum of the displacements due to individual waves. That means, say for example, if you assume that, uh, y is equal to, say if y is the resultant wave displacement, then it can be obtained as y1 plus y2. This y1 and y2 are the displacements of the first wave and second wave at a time t1 seconds. Okay, time t1 seconds daggara first wave displacement y1 and second wave displacement is y2. Then the resultant wave displacement is given by y is equal to y1 plus y2. This is what the statement is given. Is the vector sum of the displacement due to the individual waves. Y1 is the displacement of first wave and y2 is the displacement of second wave. So the resultant will be y1 plus y2. The vector sum of y1 plus y2 gives you the resultant displacement. That is what actually principle of superposition states. Did you write the statement?
Yes, sir.
In the given, in the next line you just write it. Y is equal to y1 plus y2.
Okay, sir.
And y is the resultant wave displacement. Y1 is the first wave displacement. Y2 is the second wave displacement. Okay. Now, so resultant wave displacement is nothing but the vector sum of individual wave displacements. అంటే ఇండివిజువల్ వేవ్ డిస్ప్లేస్మెంట్స్ ఏవైతే ఉన్నాయో వాటన్నింటినీ మీరు యాడ్ చేసి చూస్తే రిజల్టెంట్ వేవ్ యొక్క డిస్ప్లేస్మెంట్ ఎంత అని తెలుస్తుంది. This is the case with two sources. Say for example, if you have n number of sources, that means n number of waves are being superimposed, then you can write it as y is equal to y1 plus y2 plus y3 plus y4 plus and so on up to yn. N number of sources are there if there are n number of sources. Okay. So this is the displacement caused by first wave. That is what you are calling y1. And the second source also generates similar kind of displacement, that is y2. When these two waves are superposed, the resultant appears. Observe it. You see, this is the displacement of the. Please be online. CR is calling. Hello. Hello. Yeah, మీరు బయటికి వెళ్ళిపోయారా ఇప్పుడు ఇప్పుడు రావడమా? ఓకే ఓకే. Asking to allow them. Okay then. You see, this is y1 displacement of first wave. This is y2 displacement of the second wave. At the same instant of time, if you draw a graph on x-axis, time will be there. So, see, at a given instant of time, this is the displacement of first wave. This is the displacement of second wave. So the resultant will be superposition of these two. That is y1 plus y2. ఇప్పుడు మనం y అని రాసిన దాన్ని వీళ్ళు రిజల్టెంట్ డిస్ప్లేస్మెంట్ ని r అని రాస్తున్నారు. సో r ఈక్వల్స్ టు ఏమవుతుంది, y1 plus y2 వెక్టర్ సమ్ ఆఫ్ ఇండివిజువల్ వేవ్ డిస్ప్లేస్మెంట్స్. ఓకే. అఫ్ కోర్స్ ఇప్పుడు చెప్పిన కేసు ఏంటంటే మీకు when both the waves which are superimposing with each other having the same displacement, then obviously y1 is equal to y2. Then it will become 2y. The resultant will be 2y. R is equal to 2y. y1 plus y2 is equal to y if you assume like that. సో ఇప్పుడు ఏం చెప్పారు ఇంతకు ముందు చూడండి. సో నెక్స్ట్ క్లాస్ ఎన్ని గంటలు మీకు?
11:10 సార్.
లేదు సార్, క్లాస్ లేదు సార్.
11:10. ఓకే. Okay, you see, in previous case, you see, if y1 and y2 both are crest points of the two waves, that is the maximum points of the two waves, then the resultant will be maximum. y1 plus y2 will be maximum. But if one is crest and another one is trough, you see, maximum displacement will be observed when y1 and y2 both have crest points. Displacements రెండు కూడా individual displacements maximum అయినప్పుడు resultant displacement maximum displacement వస్తుంది. In the second case, this is the second case. y1 is crest point, that is maximum positive direction displacement, and y2 is in negative direction, trough point. When these two are overlapping with each other, then the displacement will be minimum. When one is crest point and the other one is trough point, the superposition results into a minimum displacement. Okay. Okay, we will continue this tomorrow because this will be completed within 10 minutes, I think. So, I will summarize you now. Please listen carefully. So, that can also be the overall summary is today's class. I am summarizing, speaking out in 1 or 2 minutes. You listen carefully. So, the light has two natures, particle nature as well as wave nature. Both particle nature and wave nature have been formulated theoretically and experimentally also. Both the theories have experimental supports and theoretical support also. And in conclusion, both theories were right. They are summarized by quantum mechanics, the advanced study of physics. So, according to quantum mechanics, light can have both particle nature as wave nature. This is what we are calling dual nature. So that will be discussed while you are dealing with quantum mechanics anyway. So, as per our requirement, the wave nature is required. That is, interference and diffraction is verified experimentally, which confirms the wave nature of light. So, according to the superposition principle, when two or more waves are traveling simultaneously in a medium, then the resultant wave displacement will be the vector sum of individual displacements at that instant of time. So this is what we are calling the superposition principle. Okay. So that is what we discussed today. So if you have any doubts, you can ask me now.
Sir, for resultant displacement, we can take R or either I, no problem. Why, sir?
No problem. That's not a problem. No problem.
We can take anything, sir, in that both.
You can take the resultant displacement either as R or Y. That is not a problem. Some textbooks specifies R and some textbooks specify Y. Both are accepted.
Okay, sir.
Okay, any other issues? Okay, you can ask me later also. That's not a problem. You need not to ask at that instant. If you ask at that instant, it will be clarified right there. That is the advantage over asking the other time. Anyway, you are allowed to ask anytime. That's not a problem.